Hi, today I'm gonna show you how to replace few buttons on the Tyros keyboard. Let's have a look at the display first, which are faulty. So as you can see, that this switch D is intermittently working. Sometimes it works, sometimes doesn't. On the right side, H button. Let's see, H button is not working at all. So two buttons are to be changed. So have a look on the left side of the panel buttons now. R and B is not switching on, and dance as well. So let's have a look again. R and B not working, and dance not working at all. Yeah, so these two buttons are to be changed as well. We've got something in the balance area as well. So how to check these buttons? I'm checking by pressing 5 times up and 5 times down. So at the end you should have the same value as previously. So for example, if you start with 100, so if you press 5 times up, so you've got 105, and 5 times down, so you should have 100 again. So let's check how this looks here. Number 5, as you can see, 5 up, it's not working all the time, but 5 down works all the time. So let's see again. 5 down works fine, and 5 up not always. So 5 up is to be changed. So I removed the board. This is the LCL board from left hand side of the display. It contains A, B, C, D, E buttons, as well as direct access and LCD contrast potentiometer as well. And this is LCR board. It contains F, G, H, I, J buttons, as well as left, right and exit buttons. So first thing I'm gonna do is to replace all of the micro switches. I'm gonna use the hot air with the temperature of 410 degrees Celsius. I'm not gonna use any other equipment like a preheater, which is very good, but for that kind of repair it's not necessary. So the hot air is the fastest and most convenient method, and it's completely fine. As you remember, only one switch here was not working, but I'm gonna replace all of them. This is because of my experience. I remember if one or two switches stop working, so it means the rest of them will stop work very shortly, so there is no point to leave them unreplaced. So now I'm gonna heat up the entire board nearby the elements that will be removed. So I heat it up a little bit. And now for around 10 seconds I'm gonna heat up the switch itself. It's gonna be melted for sure, but as I said, it's gonna be replaced, so I don't mind. Yeah, like so, it's melted. So one by one, heating up the board nearby and heating up the switch itself for around 10 seconds, and like so, all of them to be removed. It's done. So let's cool down the board for a while, and now let's remove all of the micro switches from the second board. So now we remove the contrast wheel from the screen. It does have 5 small contacts and 2 bigger fitting pads. So I'm gonna heat it up a bit with the hot air, and it will pop up in a second. Yeah, it came off rather quickly. So nothing else has melted, which is good. So now we leave that board and we do a quick inspection of the previous one, which cooled down already. Just quick look for broken tracks. So sometimes it comes off and you need additional repair to place the broken track back. But sometimes it happens. But luckily not in this repair. So these are panel buttons for Tyros. They are brand new. I need 3 of them. And these are LCD buttons for Tyros as well. I need 14 to change all of them in both boards. I'm gonna remove all of the solder from the solder pads in this board. But in the meanwhile, I forgot to show you how the contrast wheel from the display looks like. It is the wheel potentiometer with 5 contacts and 2 fitting points, fitting bigger legs. It looks like so. Yeah. So when to define when it's ready for replacing, when it's faulty. So when you turn on the contrast wheel on your display clockwise or anti-clockwise, and the contrast looks like scratch, I mean when it's not changing smoothly, but when it changes by jumping from very bright to very dark and from very dark to very bright, so it's flashing, so it means it's faulty and needs to be removed. So now I'm gonna remove all of the solder from the solder parts. I'm not gonna use hot air again because I'm not gonna melt the brand new switches, so I'm gonna use the plain solder station with solder tip and solder. So it's why the solder needs to be removed, because when I'm gonna solder in the new switches, the old solder will mess up a little bit. So it's gonna be easier without this solder. Now I'm gonna put good flags to all of the solder parts. Flux lowers the melting point, which is the temperature at which the solder starts to melt. So it's a good idea to put to all the jobs when you solder in or desoldering something. So because Tyros is 2002 production year, so it means all of the solder might be 20 years old as well as the Tyros. So sometimes there is big issues with melting the old solder. So it's why I'm doing this. It helps a lot with all of these jobs. I use the solder wick here. There are a few methods to remove the solder from the board, from the parts. One of them is the sucker, but I've got good desolder wick here, so it works like so. You put some flux and then you put some solder, new one, to the soldering tip, like so. It will melt down, it will join the old solder which is on the pads already, and it will jump into the desoldering wick very quickly, like so. One pad is done and the second pad is down. Third pad is done and fourth pad is done. So 4 pads have been done. This soldering wick is made from copper, so it means the solder will go very quickly, or much more easier, to the soldering wick than to something else, than to solder tip which is made from something else. Mine is not made from the copper, so as simple as that. Now the board is tidy and clean. I have cleaned it out with the isopropyl alcohol, almost 1% pure, to make sure there is no residue left. As you can see, now I'm putting back the flux to the solder parts just to make sure everything will be easy. As you might know, inside of the solder there is very small amount of flux which helps you to complete the soldering process, but the more flux is even better, because it prevents you from making mistakes, like for example bad joints, cold joints, or joints of bad quality. So I encourage you to use flux in all soldering and desoldering jobs. So how to solder in these microswitches. I'm not gonna use the hot air again because I don't want to melt down the stems, which are made from plastic. So I will use solder station. Soldering tip shouldn't be bold enough, because I don't want to make any bridge between terminal and the microswitch casing, which is metal. Sometimes it happens, so end of the tip should be rather thin. So I start to put all the switches on place. As you can see on the PCB, there is some descriptive layer with white drawings indicating where your elements should be put on to work. If you move them just over these drawings, so the elements like switches are not guaranteed to work, or they will not work properly. So it must be placed rather precisely before you solder it in finally. So in a second I will reposition all of the micro switches. It's just for my convenience, because it goes quicker for me if all of them are placed correctly. So how to solder in the micro switch? All of them have 4 terminals. So first thing I'm gonna do is to solder first terminal, just to prevent the switch from moving on the PCB. So it's gonna be sticked perfectly to the board, which allows me either to solder in the remaining 3 terminals or correct its position again, because sometimes it happens when you hold the switch with the tweezers, so its vertical position is a little bit unaligned, so it's frankly it's a bit higher than it should be. So you can just push it down to correct its vertical position. Sometimes it happens, because if you solder second terminal, it's over. You cannot change its position. So you can change the position only with only 1 terminal soldered in, because you can I will show you in a second. One hand with the tweezers you can change its position, and second hand you use the soldering tip to melt down the solder, so it will allow moving the element over the PCB. So this is my soldering tip, which is bent tip or needle type. This is very good for precise work, and it's not too big, it's not too bold, so it will not breach any of terminals with its casing. So we are ready for soldering. The temperature is 367 degrees. It can be a bit lower, but the temperature is fine for me, and it works fine with my solder. As you can see, to the soldering first terminal, I require some solder on my tip, on my end of the tip. It's not normal soldering, but it's the only way for sticking the switch to the PCB, and it's only done for first terminal. So as you can see, tweezers keep or try to keep switch on place, and right hand soldering in. It's done thanks to flux. It can be done before the flux from solder oxidize. So as you can see, each terminal requires another portion of solder on the soldering tip, and one by one like that soldered. Another portion of solder, and first terminal soldered again, and solder again, Yeah. And transfer to the PCB terminal. So remember, do not solder like that. This is not generic soldering. This method is only used for putting elements on place into the PCB the way they will not move. You will see in a minute how I'm soldering in the remaining terminals. So I will show you the generic soldering method. So let's check if all the switches are soldered correctly. Yeah, they don't move. And now I will do final repositioning, which is just pushing down the switches. As you can see, I push switch with the left hand, and with the right hand I melt the solder, so the switch goes down. The positioning is very important because the switch must be placed directly on the PCB, not higher, not any higher. Sometimes I even feel when I melt this first solder, and when I push a switch with the left hand, so I can feel the small jump. So this goes down then, and it's melted properly after this first probation soldering. Why it's so important? Because sometimes when you push such micro switches, like buttons on your Tyros or in your other keyboard, so you can feel how it's being pressed. So you can feel the jump, if it's correct or it's rather slow. So it means like there is something inside of it, something underneath, like some dust, some dirt, or maybe the switch is not correctly soldered in. So it's what I'm trying to avoid. This switch must be soldered in properly. So it must lay down directly on the PCB without any additional height. Alright, so now let's see how I'm doing the proper generic soldering. Everything is placed correctly, so now right hand I touch both the terminal and the PCB pad with the tip, which is very hot, and then after 1 or 2 seconds I just put a solder with my left hand. Just for a fraction of a second it melts down immediately and it's soldered in. Sometimes I touch terminal and soldering pad with the soldering tip again, just to make sure both of them are covered with the solder properly. So let's see from that side how it looks like, the generic soldering. Stage 1 heating up, and stage 2 putting the solder, and done. And again heating up, touching, soldered, heating up, putting in the solder, finished, heating up, solder, finished. Heating up, solder, finished. Heating up, putting the solder, finished. And so on and so on. So easy like that. And now visual inspection if everything is okay, because sometimes it happens, especially when you use the microscope and you use only the top view, so you've got the just one angle from the top, so you might not spot the incomplete joints. Incomplete joints is when you touch both elements but solder comes only to one of them. For example, the soldering part is only covered with the solder, but terminal is clean, is out of the solder. So looking from the many views, many angles, allows you to spot such a kind of bad joints. Now in this case everything is fine. And one last thing, isopropyl alcohol. That one I use is 99% pure, which means it leaves no residue. You need to sprinkle switches really generously. This is a hint from my experience, as I was doing such repairs many times. But when I sprinkled switches not generously and gave instrument back working to the customer, they was playing it one day or two, but after that time repaired switches stopped working again, despite they were brand new. So what was happening? It is how switch is built and how soldering works. Microswitch consists of two small metal terminals inside, which are joined when you press a button, and then current flows. Button works as supposed. When you solder switch to the PCB, a flux heated up by soldering tip goes over all hot metal elements, allowing soldering. So it goes inside of the switch to these small terminals and evaporates in a second. Evaporated flux leaves some residue, which alcohol must dissolve to make button working, so it's why you must use a generous amount of alcohol. So I recommend you to sprinkle alcohol and leave it for 15 minutes for dissolving. After that, you may clean it with cotton buds. And now I'm gonna solder in the LCD contrast wheel, but before that, again, I'm gonna use a flux and the soldering wick just to remove the remaining old solder. A flux, the soldering wick and some heat will do the job. As you can see, it goes off very quickly, very easy. So easy job. You must pay attention to the soldering wick because it's very hot and it's made from copper. So remember not to touch of the other elements on the PCB with the end of this wick, because you might desolder the other element which you not necessarily want to be desoldered, and you might not even notice it. You might notice it after some time when something is missing. So just better to observe where the end of this soldering wick goes to. From time to time I cut out the used pieces of soldering wick. It's gonna be easier for me. Some of you might want to use hot air for soldering in the wheel. In such case, you need to remember to cover the part which goes beyond of the PCB. This is the plastic part because the wheel is plastic. So in such case you need to cover it with a yellow heat resistant tape and prevent it from melting. Now the cleaning time. As you can see, there is plenty of residue. This is the yellowish part on the swab. So sometimes it takes 2, sometimes 3, sometimes 4 these cotton buds to be used. So I'm doing this until everything is white. I mean the cotton part until it's white. Let's check if I removed all of the solder completely. If so, I would be able to put all the terminals through holes without any issues, like so. So it looks fine. There is no leftovers, nothing is blocked, so that's fine. Remember, if you use hot air for such kind of job, you need to cover all of the plastic parts with the heat resistant tape. This plastic wheel goes a little bit beyond of the PCB, so you need to cover it anyway during soldering back. But I decided to use a standard soldering station. I'm not gonna use the hot air. It's gonna be too hot for me in this case, burnt fingers and so on, so not worth. So I'm putting some solder to the soldering tip and get some flux. Yeah, just to solder first terminal to prevent all elements from moving, like so. Yeah, now it's soldered, so it's not moving, so I can solder in the remaining terminals. Heating up the soldering part and the terminal, putting the solder and done. Heating up, putting the solder and done. And I'm gonna do the same, just repeating with the pushing the wheel from the underneath to make sure it lays down on the PCB properly. It's not on any height. Let's inspect it. Yeah, looks fine. So I can solder the remaining terminals. As you can see, this wheel consists of 7 terminals, 2 bigger ones. Sometimes they are connected to ground, sometimes they are just for fixing. And now I'm soldering in remaining 5 smaller terminals. So heating up, putting in the solder and done. And like so, all of the terminals one by one. So let's clean it out now. This is important thing as well, because if you leave any residue from the flags, it's active and it might get simply all metal parts or metal joints corroded after some time. So you don't want to oxidize it, you don't want to get it corroded, you don't want to get it rust. So clean it out very carefully, like so, until the bars are white. So you make sure there is no yellowish residue on it. Next board, this is one of the panel boards. We need to swap the 5 up button, which is 5th from the left side. This is that one located. So we need to see how it is described on the descriptive flyer, so we remember where is it, and we are going to swap it with that one element. This is the panel, this is the panel switch, looks like that. This is the through hole element, so not a SMD like previously I've done with the LCD. So it requires a hole, and because of this, I need to remove a little bit bolder ends of terminals, so I make sure it will fit the hole perfectly. It will be not clogged by any means. Turning on the soldering station. If you want, you might do this job with the hot air as well, but I'm showing you how to do this with soldering station. So first thing to do is to remove the malfunctioning element. So I will rip it off using the melting down the solder using the tip, like so, one by one, bit by bit, left terminal, right terminal, left terminal, right terminal, and it goes like that, like so. So now I'll clean it out. So using some flux will be helpful. It will help as usual. And the soldering wick and some heat will do the job. As you remember, it's because I want to the new switch go through its terminal, go through the hole without any issues. So I need to remove the whole solder. Yeah, looks like done. And quick cleaning now. I prefer to do it now instead of at the end, because later cotton buds will hook up on sharp elements of soldered in elements. So now terminals are being put through holes. Yeah, I bend terminals with some pliers. This is to make sure the element will not go out, because it's gonna be soldered upside down. I mean, the switch might simply fall down when not protected this way. Soldering is the same way, like heating up, putting up some solder, and done. And second terminal. Before doing this, you might to make sure the first terminal is soldered properly and the whole switch lays down on the PCB without any height, additional height. If so, you may solder the second terminal in. A quick job, like so. So now you can cut off the remaining terminal, because it doesn't have to be so long. Yeah, like that. And final inspection done. Yeah, properly, no residue, no bad quality joints. Yeah, it's straight, so it lays down on the PCB. Job done. This through-hole micro switch does not require an extra cleaning, unlike previously shown SMD micro switches, which have been soldered into LCD. So now let's put back all bolts into keyboard and check if all repairs have been successful. Left side seems to be fine. Right side looks fine. Next and previous, yeah, works fine too. Exit button looks fine, because you remember we have changed all of them. And panel buttons now, R&B works now, and it was dance is switching on as well, so works now. And 5 up button, 5 up, but we'll check all of them. So 5 times up, 5 times down, and we've got the same value, so 100. Yeah, so works fine. All repairs successful.